Hello, I'm Bob Stark and welcome to the exciting world of CNC milling. CNC stands for Computer Numerically Controlled. You have been given an assignment to create a nameplate using a 3-axis CNC milling machine. In designing and fabricating your nameplate, you will learn the basics of how to program and use these machines. And I think you will also have a lot of fun creating an original part that you can keep for yourself or give away as a present. But before we get started, let me talk a little bit about safety inside the machine shop. Before you walk into the machine shop, make sure you are not wearing open-face shoes or sandals. Next, make sure you're wearing these safety glasses. You will be using machines capable of cutting steel, so just imagine what they could do to human flesh. Always keep your hands away from all cutting tools and never get close to them until they have come to a complete stop. Be familiar with where the emergency stop buttons are located on the machine and be prepared to engage it if necessary. Should any accident occur, no matter how trivial, it must be reported to either a teaching assistant or the lab staff. And although it's obvious, there is never any fooling around inside the machine shop, never any running around or playing with the compressed air guns that are used to dust off the machines. Do not wear loose-fitting clothes, for it may get entangled in mechanisms. If your hair is long, pull it back and tie it in a rubber band or wear a hairnet. And always use common sense inside the machine shop. And although this is not a safety issue per se, machining is a dirty job, and we do not provide shop aprons for our students. So please do not wear anything that you'd hate to get a stain on. Now, having said this, let me start off by assuming that you have never had any experience inside a machine shop environment. To put a little perspective on what you're about to experience, let me tell you that I went to Brooklyn Technical High School in the 70s. And at that time, Brooklyn Tech had a lot of machine shops. And I can still remember the first time I saw metal being cut and how fascinated I was by it. It was almost a magical process watching these super hard materials being cut and formed into usable shapes. Brooklyn Tech at that time had one CNC milling machine. It was programmed using paper tape. A strange typewriter punched little holes in this very long, skinny paper tape, and then that tape was fed into the machine, and an optical reader converted those holes into the program. The machine resembled more a player piano than a modern-day CNC milling machine. You will be making your nameplates out of aluminum, and you will be using a modern, state-of-the-art CNC milling machine that has a touch-sensitive liquid crystal screen and uses modern software. But before I show you the machine and we really delve into things, I want to first talk about cutting tools and other things you may experience in the machine shop. So let's get started with that next. The first tool I want to show you is a simple twist drill. You're all probably familiar with this tool. It has flutes running up the sides, these spiral flutes. It is used in a clockwise direction to drill a hole. Now, before you use a twist drill, you must always start the hole with a center drill or a spot drill. Now, this is a double-ended spot drill. There's 2 drills on each side in case one breaks. You can turn the tool around and use it. Now, before you drill with a regular drill bit, you first drill with the spot drill, and you create a small little starter hole, and then you come in with your actual drill and complete the hole. The reason for this is it prevents walking. Without that hole, this drill would tend to go in perhaps in several directions before actually digging into the material. If you need to drill a very accurate hole, you first have to use a smaller size drill bit and then come along with this tool, which is called a reamer. The reamer is a very precision ground tool, and it will produce a very accurate internal diameter hole. Occasionally, you need to use flathead screws so that when the screw goes into the part, it's flush. To create that taper, you first drill your hole, then you follow it up with this tool, which is called a countersinking tool. It's used on a drill bit, on a drill press, and you come in, you create the countersink, and then your screw fits really nicely. At some point, you're going to have to create a hole that has threads in it. So that a screw can screw into it. The way this is created is you first drill with this, then you follow it up with this tool, which is called a tap. The tap is attached to a handle, and the tap is used to cut the threads. Into the part. The next tool I want to describe to you is a tool called an end mill. This is a flat end mill. It has cutting surfaces along the edges. It has cutting surfaces on the bottom as well. It has 4 flutes, 1, 2, 3, 4. It spins in a clockwise direction when it's cutting, and it is capable of cutting along the edge, across the top, and in any direction at all. Notice that this particular end mill, in the center, it does not have cutting surfaces. This is called a non-center cutting end mill. The end of this end mill, this part up here, is called the shank. The shank of this end mill happens to be the same diameter of the tool itself, which happens to be 3/4 of an inch. But sometimes the shank diameter does not match the diameter of the end mill. Here is its baby brother. Same exact thing, believe it or not. But this one is only 1/16 of an inch in diameter. And here the shank, you can see, is 1/4 of an inch. So it's a much bigger shank than the end mill itself. This can be used to do engraving or fine detailed work. Some end mills have a ball nose to them. This is called a ball-ended end mill or a ball-nosed end mill. When it spins, this projects a hemisphere, and it allows you to do very interesting kind of smooth machining and surface machining. You can do a free-formed shape by coming in with a ball-nose end mill. Some end mills are double-ended, just like that spot drill. This particular end mill has 2 flutes, and notice that in this particular end mill, the blades go all the way to the center, and this is called a center cutting end mill. This end mill has the advantage of not only being able to cut along the sides and through, but you could plunge directly into a piece of metal with a center cutting end mill. I think you can see the potential problem if you plunge into a piece of aluminum with an end mill that's not center cutting. When the end mill then starts to move, there'll be that little piece of material left in the center, which could cause you a little bit of trouble. So you can't plunge in with a non-center cutting end mill. Another tool you may encounter is something called a fly cutter. It rotates clockwise, and as it rotates, it goes across the surface of a material. So if you can kind of imagine, as it rotates, it will swing along here, rotating, and it will come across the surface of the material and make it really flat. Okay, so we'll be using this tool as well. It's a little difficult to see how it works, but it will be obvious when you see it in actual action. Okay, when we machine, we're probably going to be using a coolant. The coolant provides cooling during the cutting process and provides lubrication. It also prevents the chips from sticking to the end mill as the cutting process will take place. So we will be definitely using a coolant. Let me talk a little bit about what they're made out of. This end mill is a silver colored end mill. It happens to be made out of a material called HSS, for high-speed steel. This is one of the most economical kind of end mills, general purpose sort of end mills you can purchase, and it's capable of cutting many sorts of materials, mild steels, aluminum, etc. But if you are machining a very rough to machine material, difficult to machine material like a stainless steel, you may have to move out from the high-speed tool and into a tool made of something else. Sometimes you'll encounter an end mill that has a gold finish to it. This gold finish is actually a coating, and it's a titanium nitride coating. It's sometimes referred to in the industry as tin, but it's not tin. Don't confuse it with the metal tin. It's titanium nitride. It gives the tool longer life and the ability to make bigger cuts. This end mill is made out of carbide. It's called carbide micrograin. This is an extremely hard end mill, and this is capable of cutting things like stainless steel and other super alloys. This end mill is 3/4 of an inch in diameter. You can see it's fairly long, gauged next to my finger, and I can tell you, because this is a carbide micrograin end mill, I will bet you that this end mill costs over $100. This high-speed steel 3/4 inch end mill perhaps costs $25, partly because it's, one, not made out of the expensive carbide, but also it's fairly large. If it were smaller, it wouldn't be that expensive. Now, its baby little brother I showed you here, this 1/16 of an inch diameter end mill, which would be used for detailed work. This one happens to be high-speed steel, so it's not going to be too expensive, probably be about $7. Just to give you an idea of what these things cost. This particularly extra long 3/4 inch end mill with a titanium nitride coating, I can recall, was quite expensive. I think this was almost $100 as well. So these end mills can be pretty pricey. Let's take a look at the way the tools get held in the CNC milling machine. Here is a typical holder used on the machine. Notice it has this tapered shaft. It has a threaded hole in there. It has a set screw here. The end mill, notice the end mill has a flat. You can see that flat there. So this goes in like this, up with the flat, and then it is tightened. The Allen wrench is used to tighten the tool down. Okay. And that is how the tools are typically held in the milling machine. Attached to some of the tool holders are chucks. Now these chucks are used to hold drill bits. So you tighten that up by hand. Then you would use the key to make the final tightness, and you've got the drill in there. Occasionally you may see something like this. This is called a collet. You loosen this ring with a tool, the collet opens up, and then you can pull the tool out. Okay, let's take a look at some of the parts you can make on one of these CNC milling machines. Now this is a gearbox. Made, actually a prototype gearbox made for the first robotics competition a few years ago. These two plates are identical. You can see that it holds, these circular cutouts here were created to hold ball bearings. You can see one of them is in place. Through each one of those ball bearings would have gone a shaft, and there's a couple of gears mounted on this shaft, as you can see. So this gearbox was never fully assembled, but it had the ability to shift gears. A wheel got mounted in this section here, and when this gearbox was fully made, it allowed the robot to move in this direction. But as far as the machining is concerned, you can see it's a plate with a lot of hollowed out sections, And this is the kinds of things that you're going to be able to learn how to program using the CNC milling machine. Here's one of the nameplates from last year. This one was created with the class in mind. You can see it has 2 tapped holes here and here, and it has a little bit of a radius that goes along it, and this is very indicative of the kinds of nameplates you'll be able to make. You'll be able to make something that looks at least this good. Here's one of my absolute favorite objects that we ever made on the CNC milling machine. It's a 2-bladed propeller. It was made from a solid block of balsa wood, then coated with fiberglass. The way it was made, let's take a look at a poster which kind of shows how this propeller was made. The propeller started off as a solid block of balsa wood. It was put onto a jig that was clamped onto the table of the milling machine. The first thing that happened was the milling machine took a rough pass over the block of wood, creating kind of a spiral cutout into the wood. You can sort of see the propeller beginning to come out of that. After going over the propeller and creating that spiral staircase using a straight end mill, it grabbed a ball end mill and started making patterns over the propeller like that. And eventually, the top surface had been smoothed down. There you can see. One side's kind of smooth. It's a rough cut, but it's getting close. The other side still has the spiral staircase. After the entire cutting process was done, the propeller was taken off of the machine, flipped upside down. Injection foam was put underneath the propeller to support it for the next cut. And there it is, the final propeller. So if you can imagine, when the propeller was being made, a ball-ended end mill came in and started to make paths that look like this. So it came down going like this. It came down going like that. It came down going like that. Because of the ball end mill, you can cut all kinds of things. Here's another interesting part. This is made out of machinable wax, and this I think represents the patella bone. And Dr. Ateshin was working on a project wherein they were growing cartilage tissue in the shape of the patella, and the way they were going to grow it is they created a mold. This was the bottom part of the mold. There was a top part of the mold, and the 2 pieces came together, leaving a thin little gap between the 2 parts, and that's where the cartilage tissue was grown. And again, it was created with a ball nose end mill, and the ball, as you can kind of imagine, a little hard to see, but it would come in here and it would cut out all these strange shapes, coming in here and doing all of this rather difficult shaping. And it was eventually made out of stainless steel. This was just a prototype which we made in machinable wax first. Here's another interesting propeller. 3-bladed, machined out of wax, flipped over, and eventually these were all prototypes that led to the making of the final propeller.